host-based, network-based, and virtual firewalls. As I've already said, firewalls allow and deny traffic based on a set of rules, or what's called an access control list. Most work on the network and transport layers to accept or reject traffic based on port, protocol, and address. This means you could, for example, allow out of your network only HTTP traffic on TCP port 80, also HTTPS traffic on port 443, and DNS on UDP port 53, and deny everything else, if you so chose to do. Additionally, firewalls can be configured to allow or restrict access to specific IP addresses or IP ranges. More advanced firewalls work at the application layer to do deep packet inspection, or DPI, and are generally dedicated hardware firewalls. These have protocol and port-based rules, like they can allow HTTPS traffic on port 443, plus they inspect the traffic content to make sure that it is desirable and it fits to the rules that have been specified. So they could, and if you see in this example, look at the TLS handshake to verify it is HTTPS, it is genuinely HTTPS, and not SSH or Tor trying to sneak through the port just because it happens to be port 443. Firewalls that are not application level firewalls cannot do this. They only know that it is port 443, and therefore they will let it through. This is the difference between those that are just network based or based on layer 3 and 4, and those that are based on layer 7 or application or proxy firewalls that do deep packet inspection. Ingress filtering. So that means inbound traffic filtering, ingress filtering. On a home network like this one you can see here, because of NAT, no network traffic can connect into the network without an explicit port forwarding rule or demilitarized zone being set up to allow that traffic, as we have seen in the previous video. So there is little need for a firewall to block inbound traffic in most cases on a home network, because inbound traffic from real internet IPs cannot communicate to private IP addresses on an internal network. It's just not possible unless you set up that port forwarding or that demilitarized zone. Devices such as laptops running their own operating system can have their own firewalls, like Microsoft has its Windows firewall. Linux has IP tables, and these are called host-based firewalls, as you can see to the left here, illustrated on the diagram. If you were traveling using maybe a Wi-Fi hotspot or on any untrusted network, you wouldn't want untrusted devices being able to connect inbound into your device. You'd want to block all inbound traffic from that untrusted network. NAT doesn't protect you from untrusted devices on a network that you share. On all firewalls, whether they're host-based or network-based, there should be an implicit deny all to external traffic connecting inbound unless it is specifically required. And as I said, on home routers, that isn't required because of NAT. But on a host-based firewall, that may very well need to be configured. Now, egress filtering, or outgoing traffic filtering, egress filtering. A firewall can be used for blocking outbound connections. So, for example, stopping your Windows machine from communicating home to Microsoft, or DNS leaks from a VPN, or malware communicating to its command and control server. Those can all be blocked at the firewall with egress or outbound filtering. Outbound filtering is a strong use case for using a network-based NAT router firewall on a home network. An adversary that has managed to run code on your device in some way often needs the code to communicate out to complete its tasks, whether that be to inform the controller that the files have been encrypted, to steal the files, or maybe to take remote control via a RAT. A reverse shell or reverse connection is needed for this outbound connection, so that the adversary can control that device or the malware on that device. The adversary won't attempt to make inbound connections in almost all cases because they know that those don't work. NAT blocks it, and firewalls have default block inbound connections that aren't implicitly allowed. So attackers make connections out once they have a foothold on your device using their malware. This connection out, as I said, is the reverse shell. It's the reverse connection. And the code that runs these reverse connections is called shell code. So if you hear that term shell code, it is the code designed specifically to connect out and gain remote control. If you look at websites that have exploit code, you will see the term shell code used, and that is what it means, to create a reverse shell. And a reverse shell often creates a shell command. So that would mean CMD on Windows or terminal on Linux or OS X. Or with more automated malware, it would simply use the outbound connection to complete an automated task. Also, IRC channels are very often used to connect out to using these reverse connections. And for your curiosity, here is the code required to create reverse shells in various different languages. So here's Bash and Perl and Python, PHP, and there you can see Netcat as well. Reverse shells connecting out, enabling the remote control of a device. The bottom line is that outbound connections from a home network to an internet IP address is how malware communicates, not via inbound connections. So we've just talked about inbound and outbound filtering. Firewalls can also be used for network isolation or segmenting the network. There is a growing use case for using a firewall to block traffic between devices on the internal home network. This will be to prevent the propagation of an attack from internal device to another internal device. A firewall can be used to do this, but also a router and a switch can be used to create network isolation, as well as a Wi-Fi access point, but only if they have that available in their configuration. Do you have trusted and untrusted devices on your internal network that you want to have network isolation between? Internet of Things devices increasingly should be considered untrusted and isolated from devices that you care about. I mean, is your TV connected to your internal network? Is it patched? Is it vulnerable? It's much more likely that your Internet of Things devices have bugs, have unpatched operating systems, and are more likely to be backdoored because they just won't go through the scrutiny of the mainstream operating systems that you'll be running on your laptop or your desktop. We'll talk more about network isolation later on in this section. On a home network, there are three possible types of firewalls that you might consider to use. First is a network-based firewall that routes traffic through one network to another. They usually have two network connections as a minimum, and on a home network they filter traffic between the local network to the internet and vice versa. That's usually their main role in a home network, from LAN to internet filtering, the inbound, the outbound filtering. And if you take it a step further, you do the network isolation, as we've just discussed. Most that will be available to you will work at the network and transport layer to accept or reject traffic based on port, protocol, and address, as I've said. The firewall could be on your router, commonly using IP tables. So for example, if you install custom firmware, that's going to give you a firewall with IP tables. And that's possibly the easiest way to get yourself a network-based firewall, is to install custom firmware with IP tables. Or you could have a separate dedicated firewall on your network, but this is less typical in a home network, but does have some benefits. Talk more about that later on. But one major disadvantage of having a network-based firewall, because you have to consider why bother having one in the first place, is that malware simply uses the ports and protocols that are allowed to communicate out. So for example, if you have malware on your device, it will be able to communicate out. You need, for example, HTTP port 80 and HTTP port 443 open to browse the internet. So malware that's running on your device most often will just use those ports that are open. If it tries other ports that don't work, it will use the ports that are open, and most often on most networks, the internet protocol ports are open. So your network-based firewall is providing no outbound protection, which isn't good. And as far as inbound connection goes, we have NAT anyway, so we have inbound protection. So that's a major disadvantage of network-based firewalls, is an inability to block outbound connections, because we cannot really distinguish between good traffic and bad traffic, unless some network firewalls can be more advanced and work at the application layer, as I've said, to do deep packet inspection, like a dedicated hardware firewall such as pfSense or Smoothwall, as you can see here. So they can inspect the traffic on port 80 and HTTPS and maybe block traffic that shouldn't be occurring. But they'd have to know, they'd have to have a signature of what they should block, so that's going to be difficult. And then even then, if the malware was sending traffic encrypted, they wouldn't be able to decrypt that traffic unless you had a certificate installed on the browser. And like I said, even if they did, what would they be looking for within the traffic in order to know to block it? So that's network-based firewalls. Then you have host-based firewalls installed on the devices that you use. You might have the Komodo firewall on a Windows laptop or IP tables on a Debian laptop. By default, IP tables comes with Linux. Windows has the Windows firewall, and Mac OS X has PF firewall and an application firewall. Because host-based firewalls are local to the system, they have the disadvantage of being on the same platform as any malware that might be installed on the device trying to attack it. Because of this, malware that takes over your device could just disable the firewall, rendering it useless. Clever malware could also use trusted software processes that are allowed through the firewall to bypass the firewall. For example, the malware could use the browser process to communicate out, and some malware does just that. Network firewalls can't be disabled by malware that's running on a device. But host-based firewalls have an advantage. They can understand what applications are running on the device, so can block traffic based on a white or blacklist of applications. This is powerful. So a good host-based firewall could, for example, allow the software you know that needs to communicate out, the trusted software. The trusted software would be allowed out of the firewall. All others would be blocked. This way, standard malware using reverse shells wouldn't be able to make an outbound connection because they would not be trusted code. But, as I said, it is possible for malware that knows what it's doing to bypass this by riding on a trusted process like the browser. This is the problem when malware is on the same device as the firewall. It's always possible for that malware to attempt to bypass the firewall.
Okay, so dinhi sa ato ang gidamo sa network based not that okay network day. Okay, so dinhi